And we're live. Welcome back to another Corona Geek, here where we talk all about cross-platform app development using Corona SDK. I'm your host, Charles McKeever, and this is holiday week. This is the end of the year, and you have time about what? Well, actually, if you're going to submit something to the store, it's too late.
Yeah, it's been too late for.
But if you want to finish up your project for the end of the year, last year we did Ship Jam. Remember that? Eric Kincaid
Oh yeah,
and
it's not too late to finish a project. You just can't. Tomorrow's the closure day, as far as I know, for Apple.
right, right. So, yeah, I would encourage you to take that Ship Jam. You can probably still find that at like shipjam.com or something like that. I think they had it on a Weebly site. But anyway, if you go over there, you can probably look at what was done last year. But the general idea was if you got a project sitting on your hard drive, go ahead and pull it out, dust it off, work on it, and get it ready, by the end of the year. The whole premise of the thing was actually ship it, but we're kind of past that. So the next best thing would be to be ready for the stores when they open back up. And I would say even if it was a holiday themed idea that you had, even if you had a Halloween game, go ahead and publish it, stick it out there, right? I mean, with the window, the people's attention for that particular topic has passed, but it doesn't mean you can't put it out in the store and be ready for next year. You can just be, you're not late for this year, you're just early for next year.
Mr. Positive. By the way, Ship Jam's down.
Oh, is it?
Their domain is expired.
Oh, okay. Well, there you go. Well, maybe
So if
that's
you
a
want it,
domain.
now it's time to go buy it.
I was gonna say, yeah, maybe that's a domain we should buy.
Yeah.
So.
Except they do that thing where it expires, they charge like twice as much for a while. Or.
Oh yeah. The domain, the registrar hangs on to it for a little while.
Yeah.
Yeah. Would you like this domain?
It only costs you an arm and a leg.
Yeah.
And a small portion of your lower intestine.
Ooh, wow. Ooh. It's not a domain I want at all. Tasty.
Don't want it.
All right. Well, hey, speaking of lower intestines, we've been working on a desktop shooter game. We've got about, what, 10? Is this 11?
This is episode 11, unless I count incorrectly.
Yeah. So we have 10 previous episodes that are all in a playlist over at youtube.com/coronageek. And we've gone through everything from adding keyboard and mouse support to how to set up your project, to how to add enemies and how to move things around and how to drop traps and sort of power-ups and all these other things. And now we're going to add, as a final cherry on top, we're going to add controller support. Yeah. So
Yay! My favorite controller.
Which one is that? That's Xbox,
That's
right?
the Xbox controller for Windows, the 360.
Okay.
The Xbox 360 controller, but for Windows.
Okay. So we're gonna add that support for the game. So it's gonna be an interesting.
Some people like the PS4 controller, but I'm not too fond of it.
Yeah.
So
Well, it's going to be an interesting show, and if you haven't already, you can check the link for the show notes. There's going to be a link to, I'll probably link to the playlist, and so you can watch everything in its entirety, but you can also download the code and just use the game. I mean, learn from it, pick it apart, unpack it. It's a great resource. What's the other thing that you wanted to cover today? You said something about a document?
yeah, so we're going to have time, I think. This show is going to go, I don't have too much to cover today. It's quick to cover the controller stuff. It's not too much to it. And then I'm going to show also the document I promised last week, just briefly. And this document, you guys need to let me know if I'm echoing or anything, too, just throughout the show. Like Charles knows, my speaker's a little bit off today. I promised last week just like a guide for people who are wanting to pick up this code and maybe a little bit lost. So what I put together was a very brief document. It's 15 pages. It's only 13 pages of real content. So we got a title screen, my little statement about it's time to move on to a new game. You can read that later if you want. And then a discussion of the major game parts. I won't go through it all, but it's just a page-by-page bit where I talk about what the different major files are and systems are in the game and where you can find them, what they're supposed to do, and maybe some additional notes. The only one that I break down with any detail is the player. Because the player is the most complicated of all of the parts, in my opinion, I took a little bit of time to break down what the methods are in it and what some of the lines of code, the segments, the sections do. so that when you're looking through the lines, you can go, oh, okay, well, this section here does this, and at least to give you a starting point before you look at the code. So that will
Okay.
be in the docs folder in the top-down shooter folder. But today's discussion is, make sure I show the right stuff. I almost showed a client product there. That would be a bad move on my part. Let's see. That's the danger, I tell you what, because Corona keeps a history of everything you've been working on, right?
Mm.
And so it's easy to click the wrong thing and like load some. Here I am live and load some secret project I'm working on for somebody, and I'm not supposed to show it yet. That'd be brilliant. Let's see. So this is what the game looks like. It's always looked like this. But today's edition is gamepad, and you won't be able to tell any difference. I'm going to go ahead and restart it. But I'll just tell you what's going on here. So we got the reticle, just like usual, and you can see my dude moving around. Now the thing is instead of using the mouse, I've slaved. In fact, you can see my mouse up here, and yet it's no longer controlling my. Here, let me hide the rest of the junk on my desktop. It's no longer controlling my reticle. I've got the left joystick on my controller doing this, and then button A on this controller is for firing, and I don't have any pickups yet, but button X is to select which pickup or which trap. So you can see, I'm pointing at the screen like you can see my finger here. You can see the bottom part there changing, and that used to be the tab key. This is button X on the Xbox controller. And then if I had traps, I could press button B, and that would drop the trap. But currently I don't have I don't have any. So let me go ahead and pause this code, or pause. I'll just shut her down here, and I'll bring the code over, and I will give you a synopsis of what I've done. So I've taken the current game the way it is, and I went into Common Lua, and I added a couple of few new variables. One of these variables is called input style, and there's two options here. We could say input style is keyboard and mouse, or input style is controller. Now, I didn't want to do anything fancy where it auto-detected the controller or anything like that. I just needed to demonstrate some real basic principles this time around. When we do our next game, I'm going to take 1 or 2 episodes, and we're going to do a thorough examination of controllers and how to deal with multiple controllers, detecting controllers, and all that good stuff. But for this time around, I just wanted to see if we could get the controller hooked up and how hard it would be, and it was quite simple. So if we put our input style on controller, and in various portions of the code here, Game Lua, Gamepad, Reticle Maker, and Main Lua, and Player Maker, it will notice that this is set, and it will change its behavior. Just before we move off here, there's 2 other variables in here. One is called reticle distance, and the other one is called move len, or length. Now, reticle distance is, let me bring up the game again.
Am I understanding this correctly? That you may have just said this, but is this going to auto detect when you're on the device, or is this going to be something that you would set and then publish for that particular platform?
This is something I mean, this is not even how I would do it to publish it. I'm just doing this purely for the demo.
Okay.
So what I am saying to the game by setting that flag is I'm saying there's going to be a controller. That's your only input. So if there's no controller, it's not going to work. So if I unplugged my controller at this point, it's not like the keyboard and mouse would start driving the game. The inputs would still be there, but it wouldn't be looking for them. And I'll show you that. I basically made an if statement that says, if this, then do keyboard and mouse. If this, do controller code.
Okay.
Which is the wrong way to do it. What you really want to do is you want to set up another interface that says, here, let's default to the keyboard and mouse because we know those are always there. And you always take those inputs for the interfaces, but then optionally allow the user to remap other inputs to game actions. And then from then on, when they play the game, those inputs would change. They would control movement. So yeah, so to answer your question in short, no, this is not for publishing. This is purely for demoing and just to get the controller code hooked up real fast.
Okay.
So what we're seeing here is me getting killed momentarily. Let's get away from these dummies. But you can see the reticle moving around. So the variable that I put in there is called reticle distance. Now, because there's no mouse controlling the reticle, it used to be that the reticle would be in the same position as the mouse cursor. See, I think you can see me moving the mouse cursor around here.
Mm-hmm.
And in keyboard and mouse mode, the reticle would be, like here. They'd be the same. But because I'm using the controller input, I'm doing things a little bit differently. Instead of moving the reticle with the joystick, I'm saying, what angle is the joystick pointing? Like, is it pointing up? Is it pointing down? Is it to the left? And then I calculate a vector from the center of the screen of a certain length, and I move the reticle over there. Because if you'll remember from our original code, let me move. There we go. Or I'll just die. There we go. Pause. Okay. If you remember from our original code, the reticle would move around following the mouse, and then the character would know where the reticle was and would adjust itself to point in that direction. So I wanted to keep that same logic. I wanted the logic where the character would point in the direction the reticle was currently at. So it would be using the reticle to determine the correct facing angle. And instead I wanted to control the position of the reticle as a side effect of how the joystick was oriented. So one of the things that I had to deal with was, well, how far away from the player do I make the reticle? So at its maximum distance, it's going to be 150 pixels away. So when it's completely all the way to the right, or all the way to the left, all the way up, it's 150. But if you've looked at the controller inputs before, the axis, you'll know that they start at 0, 0, and they go up to about 1, 0, 1, 1, whatever. They limit out at 1, where 1 is the maximum extension on that axis. So +1, -1, +1, -1 for x and y respectively. And so I take a vector where the maximum length of that vector is 1, and I multiply it by the reticle distance. So when I'm barely moving the joystick, the length of that vector isn't 1 yet. So I multiply that by 150, and what that allows me to do is move the reticle just a small distance away. But when I have the joystick fully on, like all the way to the edge, then that reticle is going to be about 150 pixels away from the character at any one moment. So it gives me a nice sense. The purpose of this was, I could have just said, if the joystick is pointing, boom, push it all the way out. But that doesn't give me a sense of like how hard am I pushing the joystick? Am I doing it just a little bit? And the reason I needed that was because you'll notice that as I move the reticle, he doesn't start walking right away. So it doesn't actually start walking until the reticle is 90%, I think. Let me check. 70% of its total extension. In other words, the joystick is now hard all the way to the top, so he's walking up, or hard all the way to the left. But until it's all the way extended, it doesn't start moving. So I wanted to have the ability to move, not move, and yet still aim. So I can aim.
Oh, you don't want the character jumping around all the time while you're trying to...
Yeah, I don't want to be constantly walking in the direction that the reticle is moving, because I may walk into enemies. What I'd really like to be able to do is sit here and go, change my aim without walking. That gives me a lot more control.
Okay. Is that a pretty common problem? I mean, did you have to think that out, or what?
Oh yeah, this is one of those things where it didn't even. Let me pause, or die. Just let him die. It is a common problem, but it doesn't always arise because this game doesn't follow the traditional top-down shooter recipe, where it's not a twin-stick shooter. So with a twin-stick shooter, you're almost always moving 100%. If you pick up the game Geometry Wars and you play that for a bit, you'll be using the left joystick to move around, and I guarantee you're going to find yourself not paying any attention to how far that joystick is moving. You're just like, well, if I move to the right, I want to move 100% velocity to the right, 100 velocity to the left, etc. And then your other joystick, your right joystick, is doing the firing, and so whatever direction that joystick points in is where your bullets will go. So you can be moving to the left, but firing to the right.
So the decisions that you've made are not necessarily driven by the fact that you're using a controller, but they're driven by how you want the game to play.
Yeah, they're driven by the fact originally this game I could use the mouse and change my orientation but never walk. And I had another key for walking. And so I had to decide, do I just use the reticle in this case to decide that I'm walking? I mean, decide that I'm aiming? Or do I want the joystick to do aiming and movement? It's like doing a double purpose. And now, whereas with our previous setup, we could only aim with the reticle, now we can, in a sense, move with the reticle. Does that
Okay.
make sense?
Yep.
So, and that's where the last variable comes in. If it wasn't apparent, I have a variable here called moveLen, and basically when the vector that represents the joystick axis is at 70%, the length is 0.7 or greater, then the character will start moving. And so let me take a look. Let me show you this code. Uh, the important bit that I wanted to show you today has really nothing to do with our game. It's actually something that people get tripped up on all the time with the axis. So what you're going to see when you look at this game code is you're going to see that in Player Maker, I never find stuff when I'm looking for it. There it is. You're going to see an event called on left joystick. Now that's a custom event that I created and I dispatch. It's a runtime event that I send out like I do on SFX and on left, on right. I use all these custom events because I like to separate my code that handles processing from my code that does work. So that way the player code doesn't have to know about the input module. They can just talk via events. And another reason I did this is because the traditional way of getting the joystick axis is through the axis event. And so there is an event that you can listen for called axis right here. And you would normally say something like runtime add event listener axis. And then you can tell it the function that is your listener. Now, the problem with axis is you have to understand that an axis is one axis on the joystick. It's the x-axis or the y-axis. And it could be joystick 1 or joystick 2. So for a controller, there's 4 axes for 2 joysticks. And in fact, let me go back to my camera here for a minute. If you look at, okay, so what I'm saying here is this joystick has 2 axis events. This joystick has 2 axis events. And then it's a little bit hard to see them, but these buttons here on the hip or the shoulder, these are also axis events. And because the reason they are axis events is because, Corona, the guys I think decided that's the best way to pick them up. But they are analog events. They go between 0 and 255. That's their range. Whereas these axis events are, for each axis is between -1 and 1, approximately. It's not exactly accurate, and I'll talk to that in a minute. So back to the code. The reason why I create my own events is because if you think about it, let's get there. If you think about it, what good is knowing the X position of the joystick? You need the X and Y at the same time. Typically, when you want to move in a certain direction, you need the X and the Y component. But if only one is getting delivered at any one time, you gotta do some smart coding. So I personally don't like to use the axis event directly. Instead, what I do is I catch the axis event and then I create a record where I keep track of the last status of that joystick. For example, joystick 1, is it currently moved to the left? Okay, like I get an x-axis event, I update that. Then I get a y-axis event and I update that. And every time I get an event for that joystick, I send it out again as I dispatch a left joystick or a right joystick event where I incorporate the last X and Y value that I recorded for that joystick. So then my code that processes joystick events always gets an X and a Y value, because if we think back, movement in the game is controlled by what? It's controlled by vectors. And a vector is totally useless with only one axis. You need both axes in a 2D environment to move either up, left, or right, down. I mean, you could move, theoretically, you could deal with one axis at a time, but I find it to be counterintuitive because I know that I'm going to be doing vector calculations, etc., and only half a vector is no vector at all. So let me just walk you through this code.
I think it's a T-shirt.
Yeah, half a vector is no vector at all. I know, it could be like a math teacher or a T-shirt. Let me say two things before we go into this code. One, I just said a minute ago that the axes are between -1 and 1. That's approximate. The thing that I really can't stand about joysticks, this has always been true. Since the age of joysticks began, joysticks have been considered a noisy and inaccurate input device. They're noisy in the sense that they are analog, so they produce a tremendous number of inputs. Moving the joystick produces many more inputs than there are frames in your game. If I move the joystick to the left, in a second I may get 100 or 200 events, depending on the drivers on my computer, how often it's pulling the joystick, etc., etc. And so for us, that creates sort of a conundrum because we are going to be doing calculations based on these events. So if we're doing 200 calculations per second because we got a really noisy joystick that's producing lots and lots of events, then we got a problem. So in previous shows, I talked about a concept called what did I call it? Well, in this case, I'm going to call it throttling. That's not the term I used previously, but in a sense, what I'm doing is I'm saying, have I just processed an event for this input in this last? So let's say it's frame 10. Did I process an event in frame 10? No. Okay, then I can process it. Oh, I did? Then don't do any more processing until the next frame. So if I get 10 events in frame 10, I process the first one, I ignore the rest. Frame 11 comes along, and then it's time to get another event, and I get another event. I say, okay, I can process that one, and I'll ignore the next 10 that I get until I go to the next frame. So with joysticks, that works pretty well, but you can get yourself into a little bit of trouble. But before I go on to what the trouble is and how to solve it, let me talk about the noisiness. So in addition to another way to deal with noisiness is to set a sensitivity threshold. So the normal position for an axis when you're not touching your joystick should be 0, 0. The x-axis should be 0. The y-axis should be 0. But in reality, if you've ever had a joystick controller, you know that they don't always align perfectly. So it's like a little bit off to the left. It's stuck a little bit up. Or if you pick up your joystick, it gets a little bit of wiggling there, and so you get a little bit of movement just from picking it up. Or another really super frustrating thing for new users when they're trying to understand the axis event with a controller is they'll move the left joystick, but they'll get inputs from the right joystick. And the reason they do this is because the joysticks are super sensitive. So just a tiny bit of movement in the controller itself or near to a joystick will cause that joystick to fire off events. So if you'll see here in my code, I've got a variable called sensitivity. Now I am not using it, but I left the code in here. And the way I use sensitivity is I look at the input value for a particular axis, and I say if that value's absolute value is less than the sensitivity. So if I get an axis event of 0.1 for one of the axes, and its 0.1 is less than 0.15, I completely ignore it. I just say, that's a non-event. That didn't happen. That's a little jiggling or whatever. And this is also not a perfect solution. There are issues with this. And the issue is if you ignore all events around 0, you will never see 0. And 0 is an important event. It means that the joystick has been centered, and some action that you may have been taking, you can now stop doing. So you need to catch 0 events too. So for this example, I didn't use sensitivity. Instead, what I did, I'll finally walk through it now, is the first thing we do is I create a listener, and this is a function listener. It's not a table listener, so there's no self, there's no object that it is attached to. It's just taking an event. And I pull out the axis event. So it gets an event, and there's a field on it called axis. Now, axis is a table that contains a whole bunch of data, and I encourage people to print out or use the dump event. So go into main, re-enable SSK, and then go back into Gamepad and turn this on. And then if you do that, let me just show you what you get. Okay, let's restart the game, and I'll move the joystick around a little bit. So here you go. So you get this table here. It's a little bit hard to read because it's small, but this is the event. Axis, device, name, normalized value, raw value. And then you could dig in more. You could say, okay, we dumped the event. Let me dump the axis portion. So dump event.axis. Save that. Load it. Joystick around. All right, good. Pause it. Now we're looking at the axis event, the axis table within the event, and we have things like accuracy, descriptor, max min value, number, and type. And so these are all things that we have to look at when we are trying to extract what joystick is it, what is the value that it has, etc., etc. So for this example, let me undo this before I commit it, because we're going to commit this with no SSK requirements. I care about the axis table, and the reason I care about that is because it's going to tell me which joystick it is. It's going to tell me, is it gamepad 1, which is the controller I care about. It's going to tell me the axis number, 1, 2, 3, or 4, because the axis events for the gamepad, the two joysticks, are 1, 2, 3, and 4, where 1 is the left joystick X, 2 is the left joystick Y, 3, it's in the code here, is right joystick X, and 4 is right joystick Y. Then 5 or 6 are the trigger buttons that I showed you just a moment ago, but we're not using those in our game, so other than detailing it in the code here, we don't care. So, okay, so we're looking at the axis event, and it gives us this descriptor string where I can pull out a part of it by splitting, by breaking down the string, and I can figure out what axis this is. Or I could look directly at number. Number also will tell me the axis number for this particular axis event. Another thing I care about is the axis descriptor. And let me just remember why I care about this. Let's take a look at it. Let me dump that out. Gamepad, give me one moment. Axis descriptor is descriptor field, and the descriptor field is non-present. Did I mess up? Oh, I did mess up. Okay, I'm sorry. That was the field I was just pointing at. What I like to do is break down the descriptor field instead of looking at the number field, and the reason is the descriptor field tells you, is it a gamepad? That's the first portion of the string. Then there's a number, and it tells you which gamepad it is. So for this one, I have one gamepad attached. Let's do this again. I know it's a little bit confusing. I'm going to go ahead and attach a second joystick. You hear me going into my cabinet here. Sorry.
Going into the vault.
Yeah, I'm grabbing out of my vault of hardware. Okay, I've got two joysticks two controllers, attached. Now I'm going to move the second controller around, and you'll see now. Let's pause the game. You'll see that the event now says Gamepad 2. So this is important. If you're doing a game where you want to have 2, 3, or 4 gamepads, you need to identify the inputs. And the way to do that is to look at the event access table and then look at the descriptor field and break down the string that you get. It's going to say something like gamepad. It's going to give you a number. It's got a colon in there. I don't know why. I prefer it if it didn't, because then you got to strip it out. And I'll show you that bit below. And then it tells you access and the number. Now again, I don't need this last bit because the number is always reported as a field. But since I'm already breaking the string up, I just go ahead and break up the descriptor and then look at the individual parts. And the way I do that is I use a function that I wrote called split. Well, I didn't write it, actually. I stole it off the web. And if you want to look at the definition of split, go into common.lua towards the bottom, and you will see a piece of code here. And what it does is it takes a string, and you say, here's a string, and here is a token. Now, a token can be a colon or a space or something like that. And what you're telling this is, look at the string, find these tokens, and return to me a table of the parts of the string that are separated by these tokens. In other words, we're looking at the descriptor here, and it's gamepad space 2 colon space access space 2. So the token here is a space. So when I call split, get this all aligned, I say, here's the string, my token is a space, return to me a table, and the table is going to contain, the first entry will be gamepad, the second will be 2 colon, the third one will be access, and the fourth will be 2. These will all be strings. Then, if I want the access number, I know that that's the fourth entry in the table, I can just grab it. Now, again, for simplicity's sake, I could have simply done this. I only care that the input is coming up from a controller, and I'm not treating gamepad 2 any different from gamepad 1. I could do access.number, and let's use the toNumber function. So what I'm doing here is I'm looking at the access number field, and I'm extracting that value. But you'll notice that my dumping function here says that's a string. So I'm using the Lua toNumber converter, and I'm converting whatever that value is into a numeric value, because I'm going to use it as an index later. So it needs to be a number. And hopefully, if I didn't make any mistakes, that should work. Let's just verify that. Okay, so that works. Now that was joystick 1 or gamepad 1, but here's gamepad 2. So as I said just a moment ago, my code that I produced for this example is not sophisticated enough to differentiate gamepad 1 from gamepad 2. It's treating both inputs as the same input. It does notice if it's a left joystick or a right joystick, but that's all it cares about. So far we've said that this is a table listener. I am grabbing the access field from the event. I'm doing some math and some string operations on it. That is string operations, not math yet. And extracting the access number. And the reason I do that is, as I said, each access event is for one axis. It's the X or Y axis for that joystick, and I need to know which axis that is so I can start doing something with it. The ones I care about are axis 1 and 2, but this code down here will process 1, 2, 3, and 4 just for people who want to do a little bit more later. And the way I do that is, let me find it. At the top of the file, I created a table called joy values, joystick values. This is going to be the current value or the last value of axis 1, the last value of axis 2, 3, and 4. And I'm keeping track of these so that I can get the event, store the last value, and then create a joystick event for the X and Y for joystick 1 or the X and Y for joystick 2. Okay, so at this point in the listener, we know which axis event it is, 1, 2, 3, or 4. And so I take that number and I assign the joystick value to whatever norm value is. Now let's go back up. Norm value is, it's a little bit hard to describe, but axis events can be floating point values or integer values. So you recall that I said that the joystick inputs are between -1 and 1, but that the hip or shoulder buttons are 0 to 255. And so the normalized value is a value that has been processed by the driver that is used to read the inputs from your analog device, and it's interpreted those into some kind of useful value. And that's what gets passed in to normalized value. So if we were to run this code, and if I were to, let's go ahead and print it out. So I'm going to go ahead and add that in there and run the game again with the joystick running. Hopefully I don't have any more. You can see me moving around, and I'm getting all these interesting values here. So I'm getting minus 0.47, minus 0.96, etc., etc. Or, let me go ahead and restart so I don't get killed. If I push on the, oh, you know, that's interesting. I'll be darned. This is different. Not what I was expecting. I'm currently pushing on the triggers, and in different engines I've worked with, they treated this as 0 to 255. But it looks like they're giving me between 0 and 1. So the left trigger is completely on, all the way pressed down, or all the way up. So 0, and then I had a little bounce back. So interesting. Okay, so I just said a minute ago that the hip buttons are 0 to 255, and I'm going to have to say that I made a mistake there. That is what I get for not checking before I come on the show. I do apologize for that. Okay, so back to joysticks. Joysticks are between -1 and 1 for any particular axis. I store those values away, and that value is stored in event normalized value. So now I know the axis number, and because I know it's 1, 2, 3, or 4, I know which joystick it is, and I know the value. We're getting very close to actually being able to use this for something now. Now I have stored away the values. I started with the initial values assuming that they were 0. And now, using my throttling technique, I say, have I done an event this frame? And I got a piece of code up here that says last frame -1, enter frame, current frame is equal to the current frame plus 1. And what that does is this counter is going to go up every frame, and then when I do something, I'll store current frame into last frame. So, for example, let's say the game's running for a while. Current frame is at 10,000. I get an axis event. I look at last frame and I say, oh, last frame is -1, current frame is 10,000. I haven't done anything yet. I haven't done anything in the current frame. So what I will do is do some work and then store current frame and last frame. And now last frame and current frame are equal. And if I get an axis event at that point, I won't do anything. And so that's what this code right here is doing. It says if last frame is less than current frame, i.e. I haven't done anything yet, go ahead and fall into this code and immediately store the current frame into last frame. And then from then on, during this frame, no more work will be allowed by the axis event. I won't do any more. I won't. What's the word? I won't dispatch any more joystick events. But assuming that I have not done any work yet, I will say, is the axis number 1 or 2? That's the left joystick. Oh no. Is the axis number 3 or 4? That's the right joystick. Is it anything else? Okay, I don't care. I'm not dealing with the hip button, so we'll just ignore it. But assuming that it's the left joystick, I will dispatch an event using my post code, which is also in common, and I will send out an event called onLeftJoystick. I will put the axis number in, just in case I need it for some reason, and then I'll put a vector in there where I say x is equal to the current joystick value 1, and y is equal to the current joystick value 2. In other words, the X and Y axes, sorry, for this particular joystick. And now I have a complete event where I can make a real decision, useful, I can do useful vector math. Everything is there that I need to do the work. And interestingly, we are at 45 minutes, which is a little bit longer than I expected it to be. But the good part is, now that we know how to catch the axis event, doing the work with it is quite simple, because it's just like our old code was. Let me take you through a couple of examples.
When you say old code, you're talking about when we were doing just keyboard,
so,
mouse inputs.
previously we had code for like the keyboard and mouse, and we used vectors to do movement and stuff like that, where we're doing the same vector calculations. We're just getting the vector from a different place. We're getting it from the joystick this time. I'll show this. Let's look at the player. Okay, so the player has a piece of code called on left joystick. Now before we look at that, let's go look at the way we used to do movement. So movement done for the player was with this field called move Y. It said that if move Y was 0, you're not moving, don't move. But if move Y was anything but 0, move, and move in the direction of the sign of that value. In other words, if it's minus, then well, that's not exactly correct. This is what I get. Originally in this game, we allowed omnidirectional movement from up, down, left, right. And then I eventually restricted it to just the y-axis, moving up, which up in the world is minus y. So if move y is minus 1, that means we're moving. So if we look up here at the section called keyboard and mouse, we'll see that we were listening for the W or up key, and then when the phase of that key was down, in other words it was pressed, we would set move Y to minus 1, and then when the key was lifted, we would set it to 0. So press W or press up, and it would move in the forward direction. That's the way the player code works. If we push the key, whatever direction the player is facing, that's the direction it moves. So similarly, for the controller, we wish to move forward if the length of the controller vector is greater than 0.7, which is what I was talking about earlier. So we're going to get this event called on left joystick. It's going to contain a vector. The first thing we do is I normalize that vector, and I do so. No, I do not. I'm sorry. I look at the length of that vector, and if the vector is greater than 0.7, length greater than common move length, then I set the move Y value to minus 1, and that code feeds into our previous code with no changes and tells the prior code it's time to move forward. If, however, we get a joystick event and the length is less than the move length, we set move Y back to 0. So that's all this code does. It's a very small piece of code that is actually quite a bit shorter than the key input and does one thing. It looks at the joystick event and says, how long is that vector? I need to move forward. But the question then is, how do I know how to face? Well, you'll recall that I said that the way facing is handled in the game was handled previously to the controller is we looked at the position of the reticle. So I wanted to retain that. So I added to the reticle a left joystick listener, on left joystick. So it too listens for this new event called on left joystick. But before we look at that, let's go ahead and scroll up a little bit. And we have this section here. It says, if input style is keyboard and mouse, instead we attach a mouse listener. Now the mouse listener, if you recall, basically moved the reticle graphic to be in the same position as the mouse. And then future code would look at the position of the reticle and decide what direction the player was supposed to be facing. So what we want to do this time is we wish, in the case of using the controller input, we want to listen for a left joystick event, figure out what angle that vector is. So what that means is if you push the joystick up, that is 0 degrees. If you push it to the right, that's 90 degrees. Down is 180 degrees, and left is 270 degrees. So using the angle of the joystick, I create a vector that is based on the angle, and then multiply that by the length of the vector and the reticle distance. And then, it's easier if I run this. I move the joystick. It generates a vector that I then add to the center of the screen. And the reticle, I know this is a little bit hard to see because you're moving, so let me get this guy up in a corner. So now we can't move. You'll see that the reticle, which is probably a little bit hard to see over the forest now. Let's do this. You know, it would help if the enemy wasn't chasing me all over. Heck. But the reticle is basically following the angle of the joystick, and we convert that into a vector, a distance vector, and add that to the center of the screen. And so, really what we're controlling here with the joystick is just the position of the reticle. Everything else in the code is the same. And at this point, the code will look at the position of the reticle and say, oh, it's off to the left, so the character needs to face left. Now it's off to the right, the character needs to face right, down, face down, etc. And so we extract the angle by converting the vector into an angle. I do a thing called normalizing. Now the problem here is that the vectors that come in may equate to some kind of weird angle, but I want to keep my angles between 0 and 360 degrees. So I have a piece of code in common that looks at the angle and says, if it's a negative angle, really what that is let's say like negative 45 or negative 90 degrees. Negative 90 is equivalent to positive 270 degrees. They're in the same position. And so what this code does is it says, I don't want negative values. I just want a value between 0 and 360. So if it gets a negative value or a value greater than 360, convert it so that it's equivalent to the same angle, but now within the range 0 to 360. And what that lets me do is it lets me do consistent calculations. There are cases where when you're dealing with angles and you're trying to make a decision, that you're thinking, okay, is this value between 0 and 360? Then I'll do this. When in reality, you get this weird 720 degrees. Well, that's the equivalent of 0 degrees. But if your code wasn't written to handle it, it's not going to work. So instead of dealing with that decision all the time, I simply normalize angles when I'm working with them. And so I have this little library, which you can look at. Well, helps if you remember what you're looking for. Norm wrote. And this little tiny piece of code will normalize the rotation of a numeric value. And let me just check here. We'll also update. So for example, let's say you've rotated a display object by 720 degrees, but you'd like to clean up the rotation to make it 0. 0 and 720 are equivalent in most cases. So you can just pass in a reference to the object and it will clean up that rotation for you. So if the object rotated 360 degrees and then an additional 45 degrees, and you really wanted it to have 45 as the rotation value, you could just pass it into common norm rote and it would do the little magic on there and then change it to 45. So, all right, I've gotten off track here. So we're listening for left joystick. Left joystick in the reticle here does one thing. It positions the reticle relative to the center of the screen. It does so by getting the angle, converting that angle into a useful vector, multiplying that vector by a length, and then adding the resultant vector to the center of the screen, and we're done. All the rest of the code works just as it did before. looking at the reticle to decide on the angle of the player, and we're done. So what's left to do? We have to have key inputs to select our which trap we're going to be dropping. We need a button to fire, and then assuming that we had any traps, we need a button to drop traps. Now here's the cool thing about controllers. Controllers are mostly key events. Except for the two joysticks and the hit buttons, everything else is a key event. And so we know how to do key events already. If we look in Player Maker, we look for the controller code, you'll see that in here I've created a new key listener that only gets executed if we're in controller mode. And it is looking for button A and button B. Button A fires. It does the exact same thing as what was our fire key before? Was our mouse button. And I'm going all over the place. Where is it? And then button B, Billy, my debug note, drops traps. So I can't stress enough. Controllers are actually quite simple to deal with once you get past joysticks. So if you're looking to integrate a controller into your game, and you can get by with buttons and D-pads, then you should do that, because the D-pad events, they're all buttons, they're all keys. So are all the A, B, X, Y, and the hip buttons, the little, not the analog ones, the triggers, but the little hip buttons. Let me show this again. So on your controller, what is wrong with mine? Okay, there we go. So we've got these, which are triggers. This here is a trigger. But then you've also got these buttons, which are the hip buttons, and these are digital. They're key events. Likewise, the D-pad is a key event. These buttons up here are all key events, and these buttons here are key events. So we've got axis events, which I would say avoid unless you absolutely need them. And we're going to use them for our twin stick shooter. But you can do a lot of stuff with D-pads and buttons. And it's very quick. Learn how to use the key events, which we've already done, and you'll be good to go. Let me get off the camera here and go back to the code. So, what do we got? Firing, button A, dropping traps, button B, and the only thing left to do is handle the selection of the current trap. So this business down here at the bottom that you see moving. And so previously we did that in game. So if we go look at the game code, find it. You will see, I apologize for this. Yes, here I got super lazy, because at this point I didn't want to write separate code for the keyboard and the controller. So right now I'm running the controller mode, but if I hit the tab key, that still works. So if we look in game code, we're going to see this little key listener right here on line 326. And this key listener says, is the game running? Are the layers still valid? Yes, yes, yes. Okay, what key did you hit? Did you hit the tab key? And did you just release it? If you did, select the next HUD. That's just a little helper function in this code. And so hit the key, release, select the next HUD. Hit the key, release, select the next HUD. So instead of separating this out, I just said, oh, I got to get this code done. And I'm pretty sure that if they're using the controller, they're not using the keyboard. And really, who cares? Let them use the tab key. So I said, okay, listen for the tab, but also listen for button X. Button X is the little blue button that you just saw a minute ago on my controller. So here I'm hitting the tab key, but then I can hit button X and I get the same result. So at this point, we've mapped axis events to a separate runtime event that I then dispatch, and we've mapped that runtime event to moving the reticle. and to telling the player that it's time to move or not time to move. We've mapped button A to firing. Let's kill this guy so he doesn't kill me. And we have mapped button X to selecting the current trap that we can drop. And then I don't have any traps. Why don't I just get some here real quick? Get some. I got plenty of traps. And we have mapped button B to dropping traps. So let's drop the one that I... And our game is now functional with a controller. You know, it took me just about as long to tell you how to do this as it did for me to code this up. It's kind of sad that way. Once you've done this a couple of times, you'll find that it's quite easy. Again, most of the events are key events, and you need to look at the gamepad code that I've given you.
I'm still seeing your code. So if you're playing the game, oh, there it is. It finally came up.
Oh, you didn't see the game?
Well, it was just on my end, probably. It'll probably come out all right on the recording.
Oh, well, that's no fun. Let's do it again then. See, that was supposed to demonstrate the awesomeness of having 100 spike traps and being able to do this.
Well, I see them on the screen now.
Yeah. It's kind of laggy over here, but...
Yeah, it's a laggy over here, too. I can hear you clicking, but I don't see anything. That's okay. Go ahead.
Let's get a couple of these guys going. All right, go get them. Woo! I'm sorry. This is my favorite trap. It's the Hunt and Destroyer, I tell you. The leaf trap is just awesome.
You make a whole game just out of that.
That's right. The whole game's about leaf traps. But what I wanted to say is the one thing, if everything I said today was confusing and a little bit odd, whatever, the one takeaway is go look at the gamepad.lua code and walk through the on-axis listener, which is my function, on-axis. I could have called it axis. And step by step, print out or dump out the things that I'm grabbing here to see what's going on. But if you're going to work with axis events, I strongly encourage you to do a technique like this where you gather the axis events and then you use them. People who try to use the axis events as they come in individually will find themselves frustrated. Again, because you only get one axis event at a time. You get the X portion or the Y portion. And individually, they're only so useful. Really, they become useful together. So better to have some code, maybe not exactly like mine, but some kind of code that packages those events together so that you can use the values simultaneously, the X and Y. I find it unlikely that, I mean, having trouble even imagining a case where you would care about only the X-axis, because typically by the time you graduate to using a joystick in your game, you're doing some kind of action game or something that requires both axes, either for movement or aiming or something like that. So I hope that makes sense.
Well, I think there's some concepts here that certainly new to me. I mean, I'm not a console game developer. So there's some new concepts there to pick up and some, I don't know, some interesting distinctions between key events and axis events. So definitely go check
the big
out
thing
that.
about axis events is they are analog events. Now we have not, if you've done purely mobile development, then you will not be very familiar with analog input events. Well, actually, that's not true. Now with the new 3D Touch, people have to start thinking about analog or degrees of onness, in a sense, right? But analog events are always kind of hard to get your head around at first, but then once you get the concept, it's quite easy and natural. I mean, it's kind of weird because as game players, I'm sure many of us come from we've been playing games with the controllers all our lives. But then suddenly we're faced with having to develop for a controller, and we're like, wait a minute, this is weird. I'm getting one event at a time. That's not what I need. Or what does this mean, -1 or +1? You know, it's like, I don't know.
Well, you know, you certainly never, as a player, you don't think about the controller being noisy.
Yeah, right. And that's another thing. You don't think about how noisy the controllers are. That's the thing that has always frustrated me about joysticks, is they are inaccurate. They're not always centered, and then they're pseudo noisy. They create a lot of events. And another thing they do is, I forgot to mention this, is, well, I did say it. Remember how I said that the values are between -1 and 1? That's not true. If you think about it, the way these things work is it's a little piece of hardware that detects the relative position of the joystick. So if it's not perfectly centered, or what's the term I'm looking for here? It's when you examine the value in advance and decide that that's 0.
Like a
It'll
reference
come to
point?
me later. But the point is without knowing what the 0 value is, it could actually go beyond 1. So, for example, moving it over here could be 1.2. Well, we only care about up to 1, really. So you kind of have to trim those values off. You have to do a little massaging of the data to get your joystick properly aligned and centered, so you can decide what those inputs really mean. Is that making sense? So for example, imagine, if you will, that the x-axis on a joystick that you're using for testing is between -0.8 and 1.2. Well, you would need to really normalize that value so that it's treated as -1 to 1. Otherwise, you're going to have inaccurate motion based on that strange input that you're getting from that particular device. And then you get that all worked out, but if your code if your code is not robust, somebody else could have a controller where it's -1.2 to 0.8. That's the range it takes for X. Now, I'm giving you extreme values. It's usually much closer to 1 than that. But it's completely possible that somebody has a controller, an axis controller, that isn't centered. It doesn't produce -1 to 1 values. And so you've got to handle that in your game.
Hmm.
That said, we talked about this for now about an hour today, and we give a really just like a crash course. When we go to the twin sticks, you're going to get to see a piece of code that's a lot more robust in terms of handling joystick inputs, and we'll solve this problem of normalizing the values. So
Okay.
I didn't want to do that for this one because it would overcomplicate the discussion.
Okay, no, this was a high level. This was get us some controller support, and like you said at the beginning, it's not even something that we would ship. It's just something for educational purposes and something to kind of.
It's because somebody on the show, somebody who's being quiet on the panel, told me that I should use a joystick. Actually, I think I promised to do it in advance of that.
So, okay, so let's talk a little bit about some housekeeping items. So
Yeah.
this is the 21st. The 28th is next Monday. And then after that is the 4th, which will be January 4th, 2016. So I think we have the twin stick shooter topic that we wanted to start next week. And then the following week, the 4th, I will not be available. We will actually be at a perk event, company event in Las Vegas. So we won't have a show on that day. So, but once we pick up after that, we'll have a show as regular after that. So one of the, just as for the general audience, anybody who's watching and listening, one of the things that we want to do in the new year is we want to break up these discussions into smaller segments. So we've had an hour hangout, and that hour has either been maybe half the time's been an interview, or half the time's been code, or it's been one big long conversation. So what we want to do is we want to break it down into smaller segments, maybe like 20-minute segments. We'll still get together on those Mondays, but we'll try to break these into pieces. So if you're here watching live, then what you'll see is everything happening sort of real time. But then we will have structured everything so that we can chop the stuff up into little 20-minute segments, and that way you'll get one. We'll be covering something like, let's say, like the controllers, but we might be covering 3 different aspects of it, right? And they'll all tie together, but to complete the entire topic, but there'll be individual segments. I don't know if that makes sense. We're basically trying to make it to where we have you don't have to watch an hour's worth of Hangout in order to get what's going on. You can watch a 20-minute segment and get some value out of it like that. That makes sense, Ed? I know you and I have talked about this already, but I just want to make sure.
I just wanted to say the business with making things shorter is not only will it help us keep items sort of like tractable for people to listen to and pick up and do just a quick dive in, but the other thing is it'll force me properly to do these segments in a way where I can completely cover the topic. So saying that we can only talk about something for 30 minutes or 20 minutes, then I won't say, okay, I got to talk about joysticks and I got to connect that over here to the code. And like we did today where I try to like connect it all together, it gets a little confusing. But if I can focus on, for example, here's how the one portion of this piece of code works standing alone.
Yeah, today's conversation could have been we'll cover access, key events, and something else, right? And
we'll just cover access key events and examining each portion of the access key event, and that's good enough.
And one video, one 20-minute segment could have just been on access.
Right, and then another day could have been, okay, now that we know how the basic access works, let's make it useful. Whereas today I was like, right, here's an access, let's make it useful, let's hook it up. And so that's the kind of thing we're trying to solve by changing our format here. I mean, that's what I'm thinking.
Yeah. Okay, so that being said, next week, do we want to? What do we want to do in terms of twin stick shooter?
So what I'd like
we want to cover
is bring the twin stick shooter to you guys, show it to you, and then tell you this is the list of things that we'll be covering in the future. These are the parts that we care about.
So sort of the overview, sort of getting started video.
I'm sorry, say again?
More of the overview, sort of here's the concepts we'll cover sort of thing, more an intro to.
So this is the, just start off the discussion with no technical bits next week.
Okay. Yeah, I think that'll be a good place to start.
Okay. You can see on my screen here, I just wanted to show you that this is a future piece of code that we are going to be talking about for joysticks or for gamepads. And this gamepad controller here is detecting currently that I have two gamepads hooked up to the system, and you can see them operating independently. And we're going to go through this as a completely separate discussion where we just focus on the controller. So I have already for the show a standalone example that will let us focus entirely on these concepts, and then we'll put it into the game.
Excellent. All right. Well, that's all then that we have for today. Let's go ahead and wrap it up and invite everybody to go over to youtube.com/coronageek. Like I said before, we will link to the playlist in the show notes. You can download all the code. The playlist is going to have, at this point, 11 videos that you can go back through and watch. Everything's been broken down, and you can download the game and run it on your device and have a good old time with it. So there you go. We'll be back here next Monday to talk about twin stick shooters. Until then, have a great week and happy coding.
Cheers.